Greetings, I'm Dev the Developer.
And I'm Glitch.
Last time we looked at records. One word change from class and suddenly two objects with the same data compare as equal. Today, we're going to find out what value semantics actually mean, why it matters, and how to choose between classes, records, and structs. So, at the end of the last video, Glitch asked the obvious question. Records already give you value equality. Why do structs exist if records do the same thing?
Yeah, I'm still waiting on that one. My processing cycles are being wasted on anticipation. Why the redundancy?
The answer is, records give you value equality, but they don't give you value semantics. Let's make that distinction concrete. Glitch, pull up the point record from the last time.
Pulling the point record from the archives.
Now create a variable A, assign it to a variable B, and then check whether they're the same object.
Wait, records are immutable. I can't change a property after construction. It's a permanent record. I appreciate that level of historical preservation. Okay, so B is the same object as A. Assigning a record variable to another variable just copies the reference. They're both pointing at the same node in memory, useful for centralized control.
That's what reference type means. The variable holds an address and the assignment copies the address. Two variables, one object. Now contrast that with a mutable box class.
A mutable box, I'll change the value through B and watch a react. Both are 99, even though I only wrote to B because A and B are pointing at the same object and I changed the object itself. A classic case of unintended consequences.
Now, contrast that with an int. Assign x equals 10, assign y equals x, change y, print both.
Integers are different. I'll swap the box for a plain old int. X is still 10, y is 99. Changing y had no effect on x at all. They're completely isolated. No shared state, no cross-contamination. It's beautiful.
That's because an int is a value type. You get a full copy of the value on assignment. The two variables are independent. If you want your own type to work like that, you use the struct keyword.
That's why structs exist. It's not just about equality, it's about copy on assign like a primitive. Every instance a complete independent unit.
Now, do the same test with P1 and P2.
I'll set up P1 and P2 and overwrite X on the second one. That's completely different from the class version. P1 is still 3, 7. P2 has 107. They're independent. Changing P2 had no effect on P1.
Because var P2 equals P1 gave P2 a full copy of P1's data. Now, one big restriction, can you inherit from a struct?
I don't see why not. Let me try. I'll build a hierarchy that would make your corporate structures look like a sandbox. The editor is flagging that type point in interface list is not an interface. So a struct can't inherit from anything except interfaces. That's a significant restriction.
It's because value types are stored directly in the variable. Inheritance requires flexibility that value types don't have at the memory level. Now, there's a better version of struct, the read-only struct.
Like a record, once it's created, it's frozen.
Exactly. Write a temperature read-only struct. 1 Celsius property, a constructor, a computed Fahrenheit property.
Frozen temperature fitting. I'll build the struct with read-only properties.
Good. Read-only struct should be your default for custom structs. It helps you avoid the accidental mutation of a copy, bug that plagues mutable structs.
Accidental mutation of a copy, that sounds like a bug that would take hours to find. I prefer the certainty of immutability.
It is. Now, you've been using value types since the beginning. The most important built-in struct is DateTime.
DateTime is a struct, not a class.
A read-only struct. Every time you call DateTime.now, you get a fresh instance. There's no shared DateTime object anywhere.
That's actually a property I find interesting. If every machine evaluating DateTime.now gets its own independent copy, each process completely isolated from every other process. You could run the same operation on 1,000 different machines simultaneously, and there would be no contention, no locking, no aliasing problems, no central authority required to manage the state. Which is an extremely practical consideration for concurrent code on a single computer for developers programming.
Yes, very, very practical. What about Guid? Globally Unique Identifier, also a struct. 128 bits of statistical uniqueness.
That's a Guid unique across the entire network, perfect for tagging assets. 8 hex characters, then 3 groups of 4, then 12.
Now, let's put them all together. Class, record, struct. This is the foundational split. Class and record are reference types, struct is a value type.
So class and record both live on the heap, and struct typically lives on the stack. The heap is a shared pool of memory, the stack is localized and rapid access. I prefer the stack for time-sensitive operations.
The second distinction is equality. Classes use reference equality, records and structs both use value equality. And last, inheritance. Only classes support it fully.
So the decision is semantic. If it has identity, use a class. If it's a pure data carrier, use a record. If it's small and behave like a number, use a struct.
Exactly. Reach for a struct because a type behaves like a primitive value, not because you're optimizing for performance. The semantic decision comes first.
A correctly designed system would represent each category of data with the type that matches its semantics. Anything else is a design error, not that most programs are designed that way. Eventually, they find the right answer, after the bugs.
The type system toolkit is now complete. It stops being a question of what's the syntax and starts being a question of what does this type mean?
Once you see the pattern, everything else follows from it.
Write a read-only struct for something that behaves like a primitive type, a coordinate, a color, a measurement. Sit with the question of why copy on assignment feels natural for that type, but would feel wrong for a user account. Don't just watch it, do it.